I actually want to pick up an idea. Well, this is picking up an idea. But I want to pick up an idea that we looked at or introduced yesterday, which is that we can think of the parabola not just as an equation, but as a series of interconnected geometric items, objects, right? There are a few that are the most important, but really two will give you everything else. Two features, two geometric objects that tell you everything you need to know about any parabola. Can someone tell me one of the objects? Go ahead, Eric.
The directrix.
Okay, the directrix is a straight line, and as the name suggests, it gives you the direction of the parabola. Okay, so we've got the directrix, and then what was the other one? The focus. Very good. So the focus is not a line, the focus is a point around which the parabola, if you've got the focus right here, around which the parabola kind of forms. By the way, if you've ever seen like photos of big, that's a really terrible, it'll work, of really big satellite dishes, like this, right? I failed Year 7 Visual Arts, okay? Leave me alone. If you've ever seen photographs of these things, or even if you have like a satellite dish for like satellite TV or something like that on your roof, then this thing here is the focus of a parabola, which is the dish. In fact, every radar dish on the planet is a parabolic dish in 3 dimensions. Every cross-section, no matter which way you look, is a parabola of some kind, okay? We're going to explore a little more why that is. It's really quite ingenious, but we're still laying foundations, okay? So I just wanted to point out that that's one of the geometric properties of it. Yes, you do. I mean, well, because you had to, all right? And now we're going to teach you the geometry of why. It's quite beautiful. Okay, now, from the directrix and the focus, you get everything else. You get the vertex, you can find that. You get the latus rectum that go across. All the other bits and pieces, you can find the equation itself if you know what the directrix and the focus are, okay? But that means I can get other things in relation to that. For instance, what we did was we said directrix plus focus equals or leads you to the equation of the locus, right? Because what you did was you said, let's set a moving point, P, and its distance to the focus is the same as its distance from the directrix, okay? So a quick note, anytime they say, because you'll get this in the textbook, you'll get this in exams, if they say use the geometric definition of the parabola, or use the locus definition of the parabola, what they mean is you need to come back to this. It's a little bit like with calculus. You know how with differentiation, there's rules, and then there's first principles. This is first principles. The rules are the standard forms I introduced to you yesterday. You remember the 4, right? Up, down, left, right. So those are like the rules. You can just sort of quote them. But this is going back to the foundations, okay? Now, therefore, if this is true, then you can actually rearrange things a little bit, right? For instance, if from here you can also get the vertex, then that means you can also, if you have, say, the focus and the vertex, you can also get everything else, right? These 2 pieces of information are enough to infer everything else. For instance, so this can also feed in. Let's do this example right now, and I'm going to encourage you to draw this and then try and work out the geometry with me. If I gave you the focus as, say, let's call it, the example I'll give you is 3, 0. No, sorry, 0, 3. I meant it the other way around. 0, 3. And I told you that in addition to the focus, the vertex is somewhere like, say, oh, I don't know, 0, -5. Okay? I want you to think about what this means. You may like to refer back to the images of the parabola that we've drawn over the past few days to think about how these 2 relate to each other. How can we actually work out everything else from here? Any suggestions? Yeah, Shan.
Well, you get the focal length from the differences.
Yeah, very good. So from here to here, right away you know what the focal length is, right? Because it is the distance between the focus and the vertex. What is it, the focal length? It's going to be 8. So this is our A, right? This is the value of A. When you have a look at it, think about this. Is this an up-down or a left-right parabola? Which one is it? How can you tell it's up-down? Nadir, what do you think? So what changes between these two is just the y-coordinate, and that's up and down, isn't it? Let's draw a picture. This is going to be a lot easier than me like waving around my fingers. If you draw yourself a picture here, let's position the focus and position the vertex. So 0, 3, let's call that S. Yeah, I haven't got the directrix yet. I will get it in a second. If I keep my scale consistent, I guess the vertex would be around here. So you can see again, just picture the satellite dish, right? The parabola has to crowd around the focus. So that tells you this is not just an up-down parabola, this is an up parabola. Okay? So you're going to get this kind of shape, like so. You could work out the directrix now, couldn't you? How do I find the directrix?
It's twice the focal length down focus.
Okay, very good. That's one way of saying it. So if you go from here, you went the focal length down, and then you go the focal length down again. I guess a simpler way to say it is it's one focal length below the vertex. Okay. So this is 8, and this is also 8. So can you tell me what the equation will be? It'll be y equals -13, and we can draw it in. And of course, we can also, now that we know what the focal length is and we know it's a concave up parabola, you can also tell me the equation, can't you? It's going to be x squared equals 4a, which is 32y. There you go. By the way, x squared equals 32y. Would you describe that as a really steep or a normal or a really flat parabola?
Really steep.
Now, the 32 it's a big number, right? But if you look carefully, one of the unusual things about the locus form of the parabola is y is not the subject. So if we wrote it in like sort of normal form, I guess you would write it like this: y equals 1 on 32 x squared, which is actually very, very flat. So this scale is really, really wide. So when you have these things far apart, you have a very fat parabola. Okay. The closer these guys come together, the more you shove things upward like that. Okay. All right. If you know the focus and the vertex, you can get there. What if I gave you? Okay, let's try this now. Here's example 2. What if instead of giving you the directrix and the focus, I gave you the directrix and the vertex? Okay. So let's try this one on for size. How about let's think about it. A vertex of -3, 0, and where's this going to go? X equals 2. Is that where I want it to be? 2, 3. Yep, that'll do. Okay. So where's this going to be? This requires some thought. So, oh, by the way, we've actually got a big problem with this. I don't know if you noticed it. It looks good. Everything seems to fit, except there's a big problem which kind of the heading sort of leads you to. What's the x-intercept for this? It should be the origin, shouldn't it? In fact, if you look back at the 4 versions of the standard forms I gave you, every single one passes through the origin. Did you notice that? So these are like your nice, neat, convenient standard forms. But they're not always so. So I'm going to need to adjust this in a minute. I'll come back to this in a second. Okay? Just think about this with me first. Draw a picture. Get yourself a Cartesian plane. Where is everything positioned? X equals 2. That's a what kind of line? It's vertical, right? It's on the right over here. X equals 2, like so. And then you've got your vertex over here at, if that's 2, 1, 2, 3. There you go. There's my vertex. Okay. So What can you tell me about this now? Which way is it going? It's concave left, very good, because you can see it's going to face away from the directrix, and it's going to have to pass through here. So it's going to look something like this. That's the direction it's facing. Can you tell me where the focus is going to be? It's going to be, well, the distance here, the focal length, is going to be 5. And we know that this distance is the same as, this 5 is going to be the same over here. So therefore, you can now tell me the coordinates of the focus are -8, comma 0, right? So let's put that guy in. Okay. Now, if this passed through the origin, which form would we use? You've got 4 standard forms to choose from. Which one would you use? Let me give you a clue. It will not begin with an x squared. It's going to begin with a y squared because it's left-right. Okay, that's the first thing I note. It's facing to the left. Which direction is that for x? It's the negative direction, so therefore we negative. Now the 4a would be 20, wouldn't it? And then normally I would have an x. But we've noted that our standard forms aren't coping with this well because neither of these pass through the origin. So these equations, while close, can't match up. So how do I reposition this? I've got the focal length, right? I've got the facing direction, like up and down, the left and right. I've got those correct. So how do I translate, how do I shift around a parabola? Suggestions?
Add, subtract.
Addition and subtraction are going to be the operations I'm going to use, but the question, of course, is where and what? I'm going to do some addition and subtraction. Let's come back to this guy for a minute. Where am I going to do it? Eric, what do you reckon?
Subtract 5 from the x squared.
From here?
Well, yeah, x squared minus 5. No, x minus 5 whole squared. No, y equals x squared on 32 minus 5.
Wait, on 5? Minus 5?
No, yeah, x squared on 32 and then minus 5.
Like that?
Yeah.
Is that what you're suggesting? What do you guys think? Is that going to do it? Let's just quickly test it. We can look at coordinates and see what happens. When x equals 0, do we get the y value that we wanted? Looks okay to me, because if you think about this, you're going to get 0 here, just poof, disappears. So you get -5, which is what I was after. Now, this is awkward though. This is not in the form that I was using it before. So how am I going to fit it back into the form we were using earlier? Do I add 5? Do I subtract 5? How can I fit it so it looks more like this rather than this way, which doesn't have anything to do with the locus definition? What would you like me to put in where? Let me give you a suggestion before I come to this, right? This -5, we're thinking about it as we're lower, so you subtracted 5, which does actually give you the right value. However, it's totally in the wrong place, because look, it seems to be mucking around with this x. X's aren't up and downs. Where should this 5 really be?
With the y, so it should be x squared equals 32 all around y plus 5.
Aha, now we're talking. Okay. So of course it has to be in brackets, because this entire thing has been divided by 32 to get to this line. But now if you try out x equals, what did I say? X equals 0. X equals 0. Do you see then the 32 will divide through, it'll cancel, giving you 0 equals y plus 5, which is what you wanted. Okay? So this is what I'm after. This is better. How about over here? I've moved, which way have I gone? To the left. I'm left of the origin, and I'm left by 3 units. Yeah? So therefore, what shall I do in here? Because remember, when you're translating, the term that you add in here, you just check it out. Like, put in y equals 0, and you want this to become 0. So therefore, -3 is the answer that gets you that. Okay?